Hey, welcome back, everybody. In our last video, we described the wave and the characteristics of a wave, specifically as it relates to electromagnetic radiation. And we introduced two very important characteristics. One was a distance from a wave peak to the next wave over, and that distance is known as the wavelength, given by this Greek letter lambda, is what we use as the symbol to describe it. So you can have long wavelengths like the one in A, or you can have shorter wavelengths like the one in B. The distance is just shorter. He also described frequency, and frequency was like if I were standing, let's say this were me right here, and I'm standing and I'm counting as the waves pass me by. Let's say that that wave is moving towards me, and I count every time a single peak passes me. I'm counting the frequency of that wave. It's measured, it is a measure of how often something occurs over a given time. So while the wavelength might be measured in meters or nanometers or something like that, we say that frequency, which is given by the Greek letter nu, is typically measured in hertz or 1/2 second. Now, here's the important thing. It's clear to me that on this shorter wavelength, if I'm standing in the same location and I'm counting, go back, and I'm counting as wave peaks pass me by, I'm going to be counting faster for this wave at the bottom than I do for the one at the top. And so we would say that this wave is high frequency, but short wavelength. Whereas this one is relatively low frequency, but a much longer wavelength. In other words, these characteristics are inversely proportional to one another. When one gets big, the other gets small. So, how are they related? Well, they're actually related by their speed because they both move at the same exact speed. We know that speed. It's called the speed of light. And the speed of light in a vacuum is a known quantity. It's 3 times 10 to the eighth meters per second, which is incredibly fast. If you think about, it takes about 8 minutes for light to travel from the sun to the earth, which is about 93 million miles. It's moving very fast. So, what we want to do is connect all three characteristics speed, wavelength, and frequency into one relationship if we can. And we have a simple equation to do that. It's this one right here. Says nu is equal to c over lambda. Nu is our frequency, c is the speed of light, and lambda is our wavelength. So let's put this into action. The first problem, it says calculate the frequency of light that has a wavelength of 780 nanometers. Not a hard problem. We really just need to plug in that wavelength and the speed of light. But here's what you'll notice. When I go to do that, the speed of light is always given as 3 times 10 to the eighth meters per second. And so if I put in 780 nanometers, I am going to get this calculation wrong. I need to change that nanometers into meters. Here's the easiest way to do it. If I look at my Greek prefix chart, nano means times 10 to the minus 9. So if I just replace the nano with times 10 to the minus 9, that puts me into meters. And now I can do my calculation. So I'm going to say 3 times 10 to the 8th using the E button on my calculator divided by 780 E negative 9. And I get a very, very, very large number. I get 3.84 times 10 to the 14th. And the unit here, meters cancel out, is 1 over a second. That's the frequency of that light. So let's do a problem that's similar. Calculate the wavelength of light with a frequency of 4.56 times 10 to the 15th per second. So again, I'm going to just plug into my equation, but I'm going to rearrange the equation first. If nu is equal to c over lambda, then lambda is equal to c over nu. So my wavelength is equal to 3 times 10 to the 8th meters per second divided by my frequency, 4.56 times 10 to the 15th, 1 over a second. Again, plug that into my calculator, and we get 3 E button 8 divided by 4.56 E15. And I get, in this case, 6.58 times 10 to the minus 8, and this is meters because seconds cancel out. Great. In our next video, we're going to discuss the energy that's associated with each one of each type of radiation that we come across. So until then, we'll see you next time.